Welcome you all to the Research Spark YouTube channel. We are going to discuss the introduction to linear ICs since this is the second part of the unit second of the course analog and linear electronic circuits. So in this session mostly we are going to talk about the power amplifiers. Here we'll see the two different types of the power amplifier, that is class A amplifier configuration and class AB, that is also being called as a push-pull complementary amplifier configuration. So let us start from the basics of the power amplifiers. So simply, what do you mean by the term power amplifier? So amplifier, we have already studied the BJT based amplifier. But if you remember that amplifiers have the very less amplification factor, as well as the whatever the voltage or the current we are dealing there, that are small. But here we are going to use the higher voltage, higher current. That is why the power will be higher, since power can be the calculated as V into I, so power will be higher. That is why the amplifier is specified as a power amplifier. So power transistor, first of all, how will you make? So definitely it will have the large area devices compared to the small signal based amplifier. Because of the large area now and the doping concentration are different, so definitely all the properties will be the different. So first check these properties, compare with the small signal BJT. VCE, again VCE will be the much higher in the range of the 100 to 50, maximum it may be the 250 for BJT power. Power BZT, that is 2N6078, and while maximum VCE will be the 40, that is max for the small signal BZT. So it is almost 4 times higher than IC, that is the collector current. Only it is in the range of the milliampere for the small signal, while for the power it may be in the 10 ampere or 15, maximum 15 ampere. So the product of both V and I is much higher than the product of V of I compared to the small signal BCT. So that is why this is being called as a power amplifier. You can check out the all the other compared data. So now classes of the amplifier configuration. So we can have the four different types of the classes: class A, class B, class AB, and class C. However, in this session we are going to discuss only the class A and class AB type of the configuration. So if we'll check what are the primary differences in between the class A and class AB amplifiers are in a class A operation, an output transistor is biased at a quiescent current IQ and the conducts for entire cycle of the input signal. Means whatever the input signals we are giving, it will conduct for entire cycle. However, for class B, it will conduct only for half cycle. However, in class AB operation, it will conduct in between the whole cycle and the half cycle. It means the class AB is the mix of class A and class B. That is why this is being called as class AB. Here the output transistor is biased at a small quiescent current IQ and conducts for a slightly more than of a half cycle. In contrast, class C operation and output transistor conducts for less than a half cycle. So now let's check the class A amplifier configuration. So it is very simple, and as like previously whatever that we have discussed, the common emitter amplifier. So this is very similar to that. See, again we are going to supply the input voltage across the base terminal, and we will collect the output voltage across at the collector terminal. So this is the same. Here the only thing is that the voltage and the currents that we are going to achieve that are higher. So again we are going to supply the input voltage, and we will use that the Q point, that is the intersection point of the DC and the AC load line, and we can find out the VCC and ICQ, and then we can find out the efficiency. So this is very similar configuration that the for as we have studied during the study of the common emitter amplifier. So here the we can find out the V and I, like IC will be the ICQ plus IP sin omega t. IP sin omega is t is due to the input signal that we are supplying, or that is the input voltage that exactly we wanted to amplify with this class A type of amplifier. Similarly, VCE will be the VCC by 2 minus VP sin omega t, and we can find out the power that is the product of V and I. Now, if we wanted to maximize the power, that is the maximum, how can we, in order to maximize the efficiency, we can calculate it. The efficiency can be written as the signal load power divided by the total supply power, whatever we are supplying. So if you wanted to find the maximum, then you can have we can make it approximate, and finally if we will calculate, it will comes the 25% only. So the efficiency for this class A type of power amplifier is only 25%. This is actually the example of the class A power amplifier. So here it's very similar to the regular class A amplifier. You can see here the major difference is that now we are going to deal with the higher power, and Pmax now it can be utilized with the different coupling. Like here the example is shown using the inductive coupled. Similarly, the instead of the inductor, you can also use the transformer, that is also called the transformer coupled, and so on. So here if you will check, then the power that we are calculating, that is PL max, is the half of ICQ square RL. So this will be the V square CC divided by twice of RL, and PS, that is the source power, is equal to the simply V into IC. So this will be the V square CC divided by R. So finally the efficiency will be higher, and that will be the 50%. So here is the now another structure. This design is showing for the class AB, that is push-pull complementary amplifier configuration. So here now if you will check, then there are the two transistors. One is PNP and another is an NPN. So you can say that the NPN, the N transistor or P transistor. So what is the different? In previously, that is class A, we saw that only there was a one transistor. Here there are two transistors. So input voltage will divided into both of them. That is the positive cycle will divided in positive and negative cycle, both will be divided to the different transistor, and both of them will get amplified through this push-pull type of the complementary amplified configuration. So why are we doing that? Because crossover distortion can be eliminated by applying a small quiescent bias on each output transistor for a zero input signal. So this is the advantage over the class A. And if Q and QP are matched, then the input voltage that we are supplying, that is VI, this can be the divided to 2, and that will be the appears like VBB divided by 2 is applied. If both are same, then ICN and ICP we can calculate, and both of them will be equal. From the diode current itself we can calculate, that is IS, the saturation current, into e to the power of VBB. BB is stands for your the voltage that we are supplying through the base terminal and biased, and VT is the threshold voltage of your transistor. That is, you can also the say that it's the VT of the diode. And V out. So similarly, you can calculate the V out. V out will be the VI, that is the input voltage, plus VV by 2 and minus VV, and that is the voltage will drop across the the NPN transistor. So usually it will be the 0.7 volt. So with the help of this, we can calculate the power, that will be the V into I. So just see here the characteristic of the class AB output states. So first one is saying the voltage transfer curve. Second one is the really the inputs that we are supplying through the V1, that is the base terminal of both the transistor, and the collector current is showing, like collector current is showing that the ICN and ICP both are the here it's showing the finally the output current will be the looks like as the D. You can find in the last graph. So in this manner we can find out the power efficiency, and the power efficiency will be the product of IC and the VCE. So that will be the in between the almost 50 or 70%. So this is the high. This is the your power efficiency will be higher than the class A and lower than the class B. So that is why this is also called as a class AB type of amplifier. Some more things about the class AB amplifier. First thing is the why this is being called as the push-pull complementary amplifier configuration. So since it have the pair of the complementary transistor, that is PNP and NPN, as you saw in the design, so that's why this is being called as the push-pull. Also the same similar type of design can be used for the MOSFET based power class AB amplifier. The transistor work in a push-pull manner, meaning one handles the positive half and the another will handles the negative half. And class AB biasing each transistor is slightly biased in the conducting region, ensuring both transistors are on for a small portion. That is why we have supplied the VBB, so that it will conduct. Otherwise, your device may not conduct. And it will also reduce the crossover distortion in your class B amplifier. So the distortion is lesser than the class B type of amplifier in the class AB, but still it will be higher than the class. And efficiency, it is the more efficient than the class A. However, it's having the less efficiency with in comparison to the class B. An example of the class AB power amplifier again. So the only difference from the class AB amplifier is again the dealing with the now we are dealing with the higher power, that is voltage and current. So in this class AB power amplifier, now we are using the two different diodes which is being used as a push and pull. Also, first one will act as a positive half and the second will pass this a negative half. So finally we'll get the output across the RL. And so it can be, it can be designed based on the D1 and D2, that is two different diodes. And similarly, in the right side, if we'll check, then the class AB output is stays with the input buffer transistor. So here we can use the transistor as well to design the class AB amplifier type of amplifier. So that's all in this session. In the next session, we will see the I0 operational amplifier OPMP, and we'll also see the IC package, that is IC741, and we'll check the characteristic of operational amplifier. Thank you for listening me. If you have any doubts, please drop your comments. Thank you.